great. Now I have it in memory. Oh, but now I need a NumArray version. And so I would have to copy it over to NumArray. And so if you're talking about gigabytes of memory, that's really a non-starter. And so this is a problem. We can't have libraries built on top of different array objects that don't share data in common ways. So that was why NumPy exists, because I saw the problem. There weren't that many people who could do anything about it. I didn't know that I could do anything about it either. I was a professor of electrical computer engineering focused on electromagnetism and signal processing who used these libraries and knew some C, but I wasn't a creator of languages and type systems. And I understood the SciPy extension capability, the Python extension capability. And I wished I'd had me now to advise me then, because there's tons of stuff I didn't know. And it's embarrassing because it's in the code now, and it's like the community's just recovering from that, honestly. So, but I guess I say that because, look, desire is important, and you do your best you can, but you're not going to be perfect. And that's what open source can help you with, is actually make it better. And it takes a little bit of it's okay. You don't have to. A lot of young people I meet, they sort of have this impression that the first thing they do has got to be perfect. And it really can stall development. It can really stall doing something. I would say the most important thing is be productive, do things, get things shipped, and then be open to feedback. And you put the more effort you put into something, it's your baby. You put it out there. You want people to like it. And what I realized, and people did like what I produced, but not because they were critical technically. In fact, I needed some of that technical criticism because there's, my NumPy. So I wrote NumPy in 2005. It took about another year for it to stabilize.
There's a few threads that you mentioned in there that remind me of my interview with Wes McKinney, who created Pandas. Sure. So we had him in episode number 523. And he created Pandas because it was a need that he had. Yep. And similar to what you're describing with NumPy, if he could go back in time, he would do it all very differently. And like you, he is doing that. So things like the Apache Arrow project that he now does is to deal with some of the key limitations that are now baked into Pandas. And so, it's interesting to see that kind of parallel journey.
Yeah. So in fact, what I'd love to see, one of the challenges both of us have faced is that funding for that is not prevalent, right? Like there really isn't a space to go and say, oh, cool, you want to you want to make NumPy better? Cool, here's $1 million. Or here's instead you have to go create a company idea and then try to get funding for that company. And then hopefully some of that money for the company can go back to fund the project. And so, but it's not really solid. Yes, there are now some grants you can get, but grant applications can be challenging because that's a whole other style. Anyway, so there's multiple parallels with Wes, and I've been Wes and I are friends. We've talked for years, and I'm always looking for where can I help. I'd like to think I could code, and I can code a little bit, but a lot of people code much faster than I do. Mostly, what I really do well is help architect. Like I said, if I could help me younger, I could have really helped me younger. If we could somehow get that time machine loop going.
And there would be no harmful consequences to that at all. Everything would go
perfectly. Of course not. No.
So I really quickly here, I can't remember now. Oh, I think it was talking about how NumPy was distributed, or I can't remember exactly what put me on this.
NumPy wasn't distributed, but it needed GPUs. It didn't have GPU support, nor was it working on more than one node. That was another area. Yeah, that actually leads to the Anaconda story, right?
Yeah.
Those problems there.